In this video I will talk about loss functions and explain why they are needed. So if you are familiar with this concept, feel free to skip the video. Otherwise, let me open Paint and make a sketch. A loss function is basically something, well, obviously a function, that takes the output of the network and the expected output of the network and tells you how well the network performed. So let me go right ahead and say, okay, give me a second. So let's say that the output of the network was, I don't know, 0.3, and the expected output was actually 1, 1. So clearly in this case, the network got it wrong, right? The network said 0 and 0.3 when the actual output was 1, 1. So it's not very close, I would say. So this is the output. This column has the outputs. And this column has the actual, or let's call it the target. So the thing we wanted the network to say. And let's say that for a second example, the network said 0.8 and 1, and the expected result was 0.71. Well, this looks much better than the first case, right? This one is much closer. That's not what I wanted. This one looks much closer to the actual target than the first one. But I'm only making this judgment because I'm looking at the numbers and intuitively it looks like so. But things need to work in an objective way. We can't tell the computer, look at the numbers and check if they are more or less the same. No, we need to quantify this. We need to give the computer a way to take an output and a target and to tell me objectively how much they think they are alike. And that's what the loss function does. The loss function compares the actual output, the output with the actual target, and says if the things are close or not. And then we act on that information to train our network. Of course, if the mistake was really big, then we need to make more drastic changes. But if the result was very similar, maybe we just need to nudge things a little bit to the right or to the left. And that's the main idea. And as for the specific loss function we are going to be using, well, like activation functions, there's plenty of different loss functions. And depending on the thing you are doing, some are more appropriate than others. We are going to use a very simple loss function, even though it might not be the most appropriate one for the task we will be doing by the end of the series. And so in case you want to Google it, the loss function we are going to use is the MSE Loss Function. And MSE stands for mean squared error. And what we are going to do in the mean squared error loss function is take each number and pair it with the respective one. So this zero over here gets paired with this one over here, and we are going to see by how much we missed it, and we missed it by 1. So that's the difference. And then we are going to pair the 0.3, I hope you are not colorblind, with this one over here, and we're going to see by how much we missed it, and we missed it by 0.7. And then so these are the errors. Then we square them so that negative numbers become positive. And then we sum everything, so we square them, and now we sum everything and take the mean of these, because there's just 2, the mean is dividing by 2. So that's the loss function we will be using. And just to give you a little insight, maybe, so it wasn't obvious from the way I did it, but if the output was larger than the target, say in here there's the 0.8 that's larger than the 0.7, we won't. So these things are not the same. But by subtracting them, I get minus 0.1. So if I were to sum it directly to the other error, I would be summing, well, 0. And so this gives me minus 0.1. And that looks like, well, it's below 0. So if 0 means a perfect score, then minus 0.1 should be, I don't even know what. And that's why we square things. That's at least a way to understand this. We square it so negative numbers also become positive.